thanks also to Jeremy for fitting me in at very short notice. After the program was set up, the reason for why I wanted to give this only came in relatively recently, a couple of weeks ago. And it will be obvious why, from a discussion I had, why I'll mention at the end of the talk how this arose. So we're probably all fairly familiar with the standard CV evolution model. We've heard a little bit about it earlier today, but CVs, after they emerge from the common envelope state, with a period of 10, maybe 15 hours, they will gradually evolve to shorter and shorter periods until the point where they reach the period gap of about 3 hours. Now, that evolution has been quite well characterized in what has become known as the standard CV evolution model. One of the main papers about it is by these three gentlemen, Knigge, Baraf, and Patterson, who are certainly the proponents of that model. And that paper contains, among others, among a lot of formulae, that simple relationship that relates the change in the mass of the secondary star, M2 is the secondary star, the change in the mass of that M dot to the change of the orbital period P dot. Now, clearly that involves a loss of mass from the secondary star, and implies that if dm2 by dt is negative, the period change will also be negative. So, and the model says that the mass of these stars will gradually reduce due to basically a process called magnetic braking and the loss of angular momentum. And above the period gap, until they get to that point in the period gap, it's believed that that process is monotonic. According to the theory, mass just gets transformed from the secondary to the primary, or is lost from the secondary altogether. So M2 dot is negative, and therefore we should see a monotonic decrease in the period, the orbital period of these systems. Now, I've been monitoring a large number of these, about 20 of them for many years now, more than 15 years in some cases. And all but one of those have periods, orbital periods of greater than 3 hours. So they are all in this category of stars. It should be well described by the standard CV evolutionary model. I've written a couple of papers, one recently published in the AVSO on 18 eclipsing SW Sextantis stars. That was published in the AVSO journal, not the BA journal, because there's over 7 pages of dense tables of photometric observations that I think most BA journal readers would probably balk at trying to read. So the AVSO are very happy to fill their pages with tables of data. I've got another paper on 2 stars that I'll mention later in the talk, coming out in the journal, hopefully at the end of this year. But the bottom line is that of these 20 odd stars, less than half of them have, in fact, when you observe them, monotonically reducing orbital periods as predicted by the standard model. So these are plots of O minus C diagrams. We've heard about those already from Chris and others. They're basically, it's how you monitor the orbital period of a star, where you take the difference between the predicted, the observed eclipse time O and the predicted time on the basis of usually a linear ephemeris, that's C. You take O minus C and you plot that against cycle number or time. And on these plots, the dotted black line is the linear ephemeris, and a concave downward trajectory is what would represent a decreasing orbital period, which is what the standard model says should happen. And these stars do appear to behave themselves according to the standard model. And the coding is that the black points are ones from the literature that have been published, and the red points are ones I've been measuring myself over the last few years. But there's clearly, in both of these cases, a good evidence for a decreasing orbital period. However, concave upward trajectory indicates an increasing orbital period, and there's 2 stars which definitely do not have a decreasing period, and quite clearly appear to have an increasing period. And that behavior is not predicted anywhere in the standard model as it's published. So there has to be at least some additional explanation of the behavior to explain why you're seeing the period of these things increase. which appears to indicate maybe an increase in the mass, but it's not what's happening. So we don't really understand what's going on with those. And we understand even less about what's happening with a couple of stars like that. SW6, which is actually the prototype of the class of XW sextantus stars, appeared to be going along quite benignly with maybe a gentle sinusoidal period until a few years ago. It just takes a sharp reduction in period, and now it's just starting to turn up again. So what's going on there, no one knows. RW Triangulum is doing something equally bizarre. It's got a sort of a rough sinusoid that you could fit to that until again at the very end it starts to behave very erratically. So there are some strange effects going on in the behavior of these stars that a simple model certainly doesn't capture, and nobody really seems to have come up with a clear explanation of these things yet. And the final two I was going to mention are two stars that at some point in the recent past, the orbital period decided to make a very abrupt change, and these stars suddenly adopted longer periods. One is a CV, the other one, I think they're both CVs. The EP Draconis is a polar, whereas the other, the HS star, is just a regular SU Yuma, I think, CV. So yet again, that's behavior that certainly isn't explained in the standard model. And I've asked both Christian Kniga and Bob Patterson, showed them these diagrams and said, what's going on here? And they basically said, we don't know. We just do not understand why stars will suddenly do that sort of thing. So just to finish off, the last slide is, you may have heard of this chap, Professor Bradley Schaefer. He's now an emeritus professor in the States. He has written what is basically a demolition of the standard CV model. He sent me a draft of this recently because he picked up a lot of the data that I've been observing from the AAVSO, which shows some of these really weird O-C plots. And he's mentioned that quite a lot in the paper. So he sent me a draft of it. We'd already corresponded a little bit about other observations. He's been doing a lot of work on novae recently, and particularly on whether the orbital period of a nova changes before and after a nova eruption. So I had data. He's used some of my data on that, but he sent me this paper, which has a fairly provocative title. The evolutionary period changes for 52 CVs. He's done a lot of research on stars to pick up these stars, and the stark failure for the most fundamental prediction of the magnetic braking model. I will be very interested to see if he gets it published in monthly notices. This is where he's submitting it, clearly from the draft he sent me, and it'll be interesting to see who gets to referee it. But I don't think Brad would do that. He's got very strong views on this. If you start discussing it with him, he will. He's absolutely clear that the standard CV model is basically a load of rubbish, and there's an awful lot more to what goes on in these stars than they try and describe. So I await with interest this paper. So I thought it would be interesting. It was really through the correspondence I've been having by email with him within the last couple of weeks that made me think it might be interesting to expose some of that information to you and leave you to think about it, and wait with interest what comes up next. Okay, thank you.